Right now, a frozen fragment of another star system, traveling at nearly 94,000 miles per hour, is hurtling toward the inner solar system. Designated 3I Atlas, it's only the third known interstellar object ever observed. Its revised arrival date has just been confirmed, and it's weeks earlier than astronomers predicted. No visitor from another sun is coming, its message still unknown. Across the silent void between stars, a pale fragment of ancient ice cuts through the dark, traveling at 94,000 miles per hour. Its orbit is unlike anything seen before, a steep hyperbolic arc that no solar gravity could ever bind. The object is named 3I Atlas, the third known visitor from beyond our star, and with its arrival, the solar system once again becomes a crossroads between the familiar and the impossible. For centuries, every comet charted by astronomers was born from within our own celestial neighborhood, icy remnants of planetary creation lingering in the Kuiper Belt or Oort cloud. But in 2017, the detection of Oumuamua shattered that assumption, revealing a sliver of something from another sun. 2 years later, 2I Borisov confirmed it wasn't a cosmic fluke. The galaxy, it seemed, was more connected than anyone had dared to imagine. Now with 3I Atlas, the question deepens, not whether interstellar travelers exist, but what they truly are. Discovered by the Asteroid Terrestrial Impact Last Alert System, ATLAS, atop the Mauna Loa Observatory, the detection began as a faint flickering anomaly. At first it was dismissed as an ordinary long-period comet, but the orbital solution told another story. Its eccentricity exceeded 1, a value so precise that no gravitational perturbation from the outer planets could explain it. The object was not of this system. Spectroscopic readings revealed volatile ices, hydrogen cyanide, carbon monoxide, nitrogen compounds, but in strange proportions. Its albedo was unusually high, as though the surface were polished crystal. Beneath that brightness lay a riddle. Was it freshly formed, or had it been drifting for eons, preserved by the freezing darkness between stars? As it approached, the expected models began to fail. The object was accelerating, not through thrust or impact, but by an unknown force acting from within. Radiation pressure, gas jets, magnetic drag, each theory fit only part of the data. What scientists saw didn't align with any natural cometary behavior. The acceleration was smooth, continuous, deliberate. Around the world, telescopes recalibrated to follow its passage. Supercomputers ran millions of orbital simulations, yet all ended the same. 3I Atlas was inbound, sooner than anyone predicted. Its perihelion, once calculated for late spring, had advanced by nearly 21 days. Something had altered its course, and as it drew closer, its light changed. The tail glowed faintly green, a hue consistent with diatomic carbon. Yet the emission spectrum carried frequencies never before recorded from a comet. Some speculated about exotic molecular bonds. Others whispered of structure, symmetry born not of chaos but of design. Across observatories, scientists watched the anomaly unfold, unable to reconcile data with theory. The universe, once thought predictable, now pulsed with quiet contradiction. In the cold vacuum between the stars, an object moved not by chance, but perhaps by purpose. The data reveals anomalies that defy every cometary model ever written, and forces a question that science is not yet prepared to answer. What kind of object behaves like this? At 94,000 miles per hour, the interstellar object slices through the blackness, faster than any comet of known origin. Its path bends slightly, not by collision, not by gravity, but by something unseen. Across the globe, telescopes turn to follow it, their lenses aligning with a common purpose: to understand a fragment of the galaxy that refuses to obey celestial law. Within days of its discovery, the data spread like wildfire through the scientific community. The object's brightness fluctuated in ways that made no sense. Each night, 3I Atlas appeared a fraction of a magnitude brighter, then dimmer, then brighter again, as if breathing in the vacuum. Ground-based observatories from Chile, Hawaii, and Canary Islands confirmed the same anomaly. A smooth, steady acceleration, measurable only through the precision of modern astrophotometry. It was subtle, just a few millimeters per second squared, but enough to defy everything predicted by Newton and Einstein alike. When Oumuamua had performed a similar stunt years earlier, astronomers had scrambled for answers, radiation pressure, cometary jets, even alien engineering. But 3i Atlas gave science a second chance, an interstellar riddle arriving with clearer data, sharper sensors, and better eyes on the sky. Yet even with this advantage, the mystery only deepened. Infrared spectra from the James Webb Space Telescope painted an even stranger picture. Rather than the standard chemical signatures of water, carbon dioxide or methane sublimating under solar heat, Webb detected faint outgassing of molecular hydrogen and nitrogen-rich volatiles, compounds nearly impossible to preserve in open space for millions of years. At temperatures barely above absolute zero, these molecules should have evaporated long before entering the inner solar system, but they hadn't. As sunlight struck its surface, 3i Atlas responded with silent bursts of activity, like an object converting energy through unknown physics. Its tail shimmered not in dust, but in vaporized metallic ions, an iridescent whisper of the exotic materials within. Models invoking radiation-driven sublimation collapsed under scrutiny. The force driving it was too strong, too consistent, too directed. At the European Southern Observatory, data analysts noticed that the acceleration appeared aligned with its long axis, an orientation impossible for a tumbling natural body. It moved as though guided by intent. Yet physics allows no room for intent. The cosmos, scientists insisted, does not decide. It only reacts. Still, the numbers refused to conform. With every hour, 3i Atlas adjusted its trajectory, not erratically but smoothly, tracing a path of precision so exact it seemed computed. Theories multiplied, perhaps an internal chemical engine, perhaps trapped thermal energy from interstellar dust, perhaps a thin shell reflecting sunlight in a way that mimicked propulsion. But none explained the timing, the rhythm, the growing pattern. Through the deep hum of data streams, a new kind of signal began to whisper, a pattern not in radio, but in light itself. Every rotation, the object emitted a subtle modulation, a rhythmic pulse buried within the reflected spectrum. It repeated with perfect precision every 721 hours. Coincidence, some said. Statistical noise, others claimed. Yet for those watching the sky, the signal felt too deliberate to ignore. As telescopes tracked the shimmering arc of 3i Atlas across the heavens, one truth became inescapable. This was not merely a visitor. It was a message in motion, and deep within the signal, the rhythm persisted, steady, mathematical, and waiting to be understood. At precisely 7.21-hour intervals, a faint pulse ripples through the radio silence of interplanetary space. To most instruments, it is nothing more than statistical chatter, the kind of random fluctuation that fills the cosmos. But to those watching the trajectory of 3i Atlas, it is something else, something too rhythmic, too exact, too persistent to ignore. The Deep Space Network, a lattice of antennae stretching from California to Madrid to Canberra, begins to hum with curiosity. In their constant surveillance of distant spacecraft and natural phenomena, the analysts notice the same anomaly repeating, frequency spikes. Each one perfectly synchronized with 3i Atlas's rotation period. The pattern is subtle, hidden in the static like a whisper between the stars. Yet when isolated, it forms a sequence of intervals so precise that coincidence starts to feel like the least likely explanation. At the SETI Institute, the first reaction is skepticism. Natural processes, after all, can produce rhythm, rotational modulation, magnetic reconnection, gas venting, even the flicker of sunlight on uneven terrain. Teams simulate possible causes, jets of sublimating ice releasing in measured bursts, the object's magnetic field interacting with solar wind, reflections from tumbling crystalline facets. But each model collapses under precision. The pulses are too uniform, too clean, too mathematically consistent. Meanwhile, optical telescopes studying the light curve of 3i Atlas uncover a revelation. Its brightness does not vary randomly, but geometrically. The curve traces a repeating pattern consistent with flat reflective surfaces, not the chaotic contours of natural ice. Radar imaging attempts to map its shape, and what emerges defies expectation. An irregular shard, elongated and asymmetrical, yet defined by planar faces that catch sunlight with machine-like regularity. Some call it a coincidence of physics, others, symmetry by intention. If 3i Atlas is merely a remnant of a shattered planet, Then its structure holds memories of catastrophe, a relic frozen mid-destruction, wandering the interstellar dark. But if not, if its symmetry serves purpose rather than chance, then the solar system may be hosting something built, not born. The distinction between comet and construct blurs beneath the cold light of observation. For the scientists measuring the pulse, the question shifts from what the signal is to why it exists at all. Is it a byproduct of motion, a reflection of sunlight bouncing through complex internal geometry, or something deliberately encoded within its spin? The universe, vast and indifferent, does not typically repeat itself with such intention. As the data accumulates, another pattern begins to surface. The signal doesn't fade with distance, it strengthens. It fluctuates not with solar radiation, but with alignment, as though it were locking into resonance with something far beyond the sun. The rhythm becomes a metronome, ticking across space, syncing to a silent counterpart no one can yet identify. Then, one night, as the Deep Space Network continues its monitoring, a second pulse arrives, not from the comet, but from deep beyond the heliopause. Its timing is identical, its waveform mirrored, as if answering a call across light years. Suddenly, the noise is no longer just data. It is a dialogue written in physics itself, and somewhere in the distant dark the echo replies. Across 11 light-years of emptiness, a faint pulse returns, a mirror image of the signal first traced to 3I Atlas. It travels through the cosmic medium like a whisper caught between stars, bending around gravitational wells, echoing through ionized dust. Its origin, a system known to astronomers as Epsilon Eridani, one of the nearest and most studied suns beyond our own. A young orange dwarf, circled by belts of debris and the faint suspicion of planets. But this signal, rhythmic and synchronous to the rotation of 3I Atlas, speaks of something older, much older. At first, scientists hesitate to connect the two. Random coincidences, after all, are the universe's native language. But as the data converges, the probability collapses. This is no chance. The two signals are twins, separated not by frequency or form, but only by distance. The alignment is exact to the millisecond, a temporal dance spanning interstellar space. It is as if 3I Atlas is not merely passing through, but responding to something calling from the dark. Epsilon Eridani has long been a beacon for those searching for habitable worlds. Its proximity, its youth, its circumstellar dust, each hinting at planetary formation. Yet buried within the new spectroscopic data lies something unexpected. The isotopic ratios in 3I Atlas's outgassing, oxygen 18, nitrogen 15, do not match any known region near that star. Nor do they match any formation environment within the Milky Way's local spiral arm. Its molecular fingerprint suggests a place older than Sool, older than Eridani, perhaps older than the galaxy's current structure itself. Every analysis returns the same impossible result. The material composing 3I Atlas predates the Sun by nearly 2 billion years. It is, quite literally, a messenger from a forgotten age, born before Earth solidified, before life emerged from its chemical tides. Its journey may have begun in a galactic orbit so vast that even the word epoch fails to describe it. As scientists race to make sense of this cosmic echo, theories multiply. Could it be a relic of a pre-solar civilization, cast adrift across the void as a seed of knowledge, or perhaps a fragment of a world that perished long ago, ejected by the death of its parent star? Each hypothesis collides with another, the truth suspended between science and speculation. The mirrored timing of the pulses continues, steady and unwavering. Every 721 hours, 3I Atlas responds, like a clockwork heart synchronizing to a rhythm that transcends light years. Radio telescopes around the globe record each sequence with growing awe. The signal appears to carry modulation patterns, brief, structured variations that no natural emission should produce. Yet they remain indecipherable, as if encoded in a physics humanity has not yet learned to read. And then, without warning, something changes. As 3I Atlas nears its perihelion, a sudden surge of radiation bursts from its surface. In a fraction of a second, energy equivalent to a small nuclear detonation erupts without impact, without heat source, without reason. Instruments across the solar system register the flare, its spectrum defying every thermodynamic model, For a moment it shines brighter than Venus, then silence. The signal stops. The echo fades and the universe holds its breath. Somewhere beyond the reach of light, the answer is still waiting. Alive in the spaces between stars at 0.26 astronomical units from the Sun, 3i Atlas becomes a blade of light, its nucleus igniting into brilliance against the velvet of space. To the human eye it appears as a streak drawn across the heavens, a transient wound in the twilight. But to the instruments watching from Earth and orbit alike, it is a phenomenon without precedent. Its surface, once dormant ice and dust, erupts in a flare that outshines Mercury's sunlit hemisphere. For 23 seconds, space becomes a crucible. Spectrographic arrays register an outburst across multiple wavelengths, ultraviolet, infrared, even gamma. The signature matches no chemical or physical process known to natural comets. No solar wind surge, no outgassing of volatile materials, no impact event. The data is precise, energy equivalent to a controlled fusion reaction, confined to a body no wider than a mountain. At solar observatories around the world, systems overload. Filters burn out. Automated telescopes enter emergency shutdown, blinded by the radiance. For a moment, the Sun itself seems to answer the object's outcry with a flare of its own, plasma arcs twisting outward, pulled by invisible tides of electromagnetic force. And then, silence, the brightness collapses. The instruments, once deafened by data, return to static. 3i Atlas drifts on untouched, its geometry unchanged. It does not disintegrate. It does not fragment. Instead, it steadies itself, its course recalibrated with mathematical precision, as though correcting for its own ignition. Scientists rush to interpret what they've witnessed. Some propose a natural resonance, perhaps superheating of trapped hydrogen compounds beneath a crystalline crust. Others whisper of something more deliberate, an engineered reaction, a kind of propulsion system designed not to travel, but to endure. Within the faint plasma wake that follows, spectroscopy reveals elements unknown to any terrestrial database. Heavy isotopes of beryllium and xenon appear, metals that should not exist in this ratio, not in this galaxy, not even in the known periodic stability zones. Whatever occurred within that 23-second window, it changed more than just trajectory. The object's rotational pattern slows by 0.03%, small but deliberate. It now spins in synchrony with the orbital period of Epsilon Eridani b, the very world tied to its mysterious echo. Coincidence or communication? As it retreats from the inner solar system, 3i Atlas leaves behind a filament of ionized particles, stretching like a spectral thread through the void. When sunlight strikes it, the trail shimmers faintly in the ultraviolet, an invisible scar to human eyes but glowing brightly in the view of high-altitude sensors. Some call it residue, others call it a signature. Weeks later, the object slips past Mars's orbit and begins to fade from view. The data stream dwindles. What remains is the memory of light, and an archive of anomalies that rewrite the limits of astrophysical understanding. No transmissions, no signals, no further eruptions, only silence, until deep within the cold expanse beyond Jupiter, something stirs again. A new object, faint, small but unmistakably aligned, emerges from the dark. Its trajectory mirrors that of 3i Atlas, with absolute precision,